Thanks for being here. I know it's the last session of the last day of a conference, and as a conference organizer myself, I find it quite surprising that a lot of people are here to listen to what I have to say. So, I'm going to talk about Flutter, and a brief introduction about myself. My name is Roberto, and I'm an Android engineer at the New York Times. That's why there is the logo there. And, well, I chose this title for my talk because actually I really loved How I Met Your Mother. It was kind of nice. But when I started showing to people my presentation, they actually asked me to change it in clicker. OK, the clicker is not working. We can do that without. To change the title in this. Doesn't really make sense for me, but, well, I like it better. So, let's get started. So, have you heard of Flutter? OK. One person. You know almost everything I'm going to say, so don't ask questions later. You can. So, actually, Flutter is a new mobile framework made by Google that helps us create mobile apps that are not only tied to Android. That's correct. It's a cross-platform framework. I'm not a fan of these kind of things, but there are a few elements in Flutter that I really, really love. Not saying that I'm going to use it tomorrow, but what I'm saying is that I might start using it for some of my projects, and I hope that I'll convince you. So, we already said that Flutter is a mobile SDK, but what we didn't say yet is that it's actually based on a language that we as Android developers or iOS developers, if there are any here in the room, are not used to. And this is Dart. It's a cool language. I mean, if you like Kotlin and Java, it can be somehow similar to those. Like you have vars and semicolons that are the two worst things for the two languages, but that's fine. But luckily, is not Dart the main point of this framework. I mean, it's an important part because we have to write in Dart in case, but it's not that bad. I'm kidding, it's bad, but I mean, you'll get used to it eventually. So, the first feature that I want to highlight is actually the fast development. The name is a bit tricky because, of course, it helps you develop faster apps. But what it is actually, have you used Instant Run on Android? How many of you used Instant Run on Android? At least tried. OK, how many of you disabled Instant Run then? Did you try JRebel? OK, how many of you find that sometimes, even if JRebel is incredibly fast, it can take quite a while to start? OK, so fast development, that is actually called hot reload in Flutter, is the right solution for this kind of project. We see later how it works, but my definition of it is instant run that works. There are a few things that don't really work yet, but again, Flutter is an alpha stage, so it makes sense that there are a few bugs. So, I didn't say the important data. It can take less than 1 second to reload the full UI, and it's stateful. That means that it will preserve the state. And this is something we're going to see in a few slides. I want to give an overview before. So the next thing that I like is the fact that it's easy to create a very beautiful UI. Because right out of the box, Flutter brings us two different themes. The first one, of course, is material design. I mean, it's from Google, so it makes sense. But they also added the Cupertino style, that is the one they use on iOS. And that is right out of the box. I'm sorry, I'm not a native English speaker. You may have got that. So I'll do my best. And of course, for every style we want, they give us a huge amount of widgets. What happens that then, since they actually don't rely on the platforms, they actually created their own system to draw the widget, so they are not using the Android or the iOS pipeline to render the widgets. Every time a new widget is released, they have to release it as well. But they already thought of that, and they made each widget so that we can actually compose them. We see the code in a minute, but imagine that you, instead of extending each class to add behavior, you can just compose the class. So inside the text view, you can put a switch and a button. I don't know why, but you can. In Flutter, you actually can do that. I don't feel really safe in this thing moving like that. If I fall down, sorry. And of course, if you don't want any widget, you have the Flutter style. I didn't try that personally because it took me a while to configure the iOS environment. I'm sorry for the iOS developers if they have to do that every day. I did it once and I really don't want to do that again in my life. And of course, as all the other cross-platform framework that we know, we have native features. What it means is that we can actually write code that is specific to Android or iOS, and we can actually call it from Flutter using an API called channel, and it will work. I mean, imagine that you want to read the battery level on your phone. I mean, we all know that is something that is tightly coupled with the system. They couldn't really implement it in Flutter. I mean, after all, it's another layer of abstraction. So what you can do is actually write in a method in your Java code, and then call it from Flutter by using the channel API. Of course, since actually our project is based on Gradle, because the structure of a Flutter project is very similar to an Android one, we can actually access every single SDK that has been released for Android or iOS. That means that we are not losing any of the knowledge that we already have. We are just adding some more complexity maybe, but we'll see that in a second. So what does it mean that it suits everyone? Well, Dart is not hard to learn. I mean, as Java developers and possibly Kotlin developers, you'll find quite a lot of similarities with Dart. There are some things that are totally new, like they were to me. For instance, I had to add an underscore before the name of the method in order to make it private. That was confusing, but it was one of the few things. The only other things that really changed was the fact that when you declare a lambda, you use the equal sign instead of the dash. For the rest, if you know Java, it's quite easy. So also for junior developers, it's not that hard to learn Flutter. And if you're wondering, yeah, but we all have our projects, why should we use Flutter? Well, imagine that you want a component, a specific component, that should behave exactly in the same way on both your platforms and should actually appear exactly in the same way on both platforms. You have different ways to do that. Either you both implement it natively, or you choose another framework, let's say React, or you just create a view in Flutter and include it as a library in your project. That means that you can actually create a Flutter library that is written in Dart with all the caveats of the case and pull it in your Android project. And of course, since we are used to IntelliJ, Flutter comes with an integration with IntelliJ. actually, we have two plugins. The first one is for Flutter itself, and the second for Dart. But you are free to use whatever you like. I mean, it's more or less like Android. I mean, you could write it with Notepad, and still it will work. But actually, Flutter is a bit more than just an SDK, because it comes with a sort of manager that is Flutter Doctor. So far, since we are still in an alpha stage, what you do when you want to start using Flutter is cloning the repo, setting a few instance variables, and then you run this doctor. What this doctor does is actually checking for all the other dependencies that it needs and tell you which of them are correctly configured and which are not. What do I mean with that? Well, we already said that Flutter is a mobile SDK that helps us writing apps for both iOS and Android. So the first things that it's going to check is that we have Android SDK installed. Because, I mean, here we assume that we are all Android developers. But as we said earlier, Flutter is not aimed exactly at us. They try to reach more people possible. So they start checking if our Android SDK is installed, together with Android Studio. And of course, the emulator, because we might need to run at some point some code. And actually, this doctor helped me quite a lot in configuring my iOS environment, because it starts checking for all the Xcode dependencies for the simulator, and I guess also if I accepted the licenses. Because I don't know if any of you are on Mac, but when I started using Mac, I was confused by the fact that every time they updated Xcode, my Git client stopped working, because I needed to accept new licenses. Yeah, of course, you get around that because you remove Xcode, but I mean, that's something that, that could have helped. So I started with the fast development, but let's actually check a bit deeper how this works. So just to give you an overview, I prepared a small animation of how it looks like. And this is actually the real speed. So you change something, you maybe add something else. These are just theming attribute. The app is already running. I zoomed in, but it was there. Then you run, and the app is there. Took less than 1 second. And actually, it does that. For most of the things you can change, the hot reload works fine. But there are a few things that actually we can't reload so fast. That are the global variable initializers. That means that we have global variables that are initialized somehow. The hot reload is not able to change them on the fly, because of course, since they get initialized before, we need to run the whole app. Same things goes for the static initializers. And if we change the main method of the app. We'll see later that a Flutter app resembles quite a lot a normal Java or Kotlin app. We have a main method that runs our whole UI. And since the hot reload cannot take the changes and apply them. So these are the 3 cases in which we cannot use hot reload, but it works in most of the cases, so it looks safe enough for me. So let's see how actually the changes are applied. So we apply some changes to our code. And this is normal. When we press the hot reload button, these changes are sent to the Dart virtual machine that interprets does not compile, but I don't know how do you pronounce that word in English? I don't know. I honestly don't know how to pronounce interpretate. Someone help me, I mean. Yeah, that one. I will not repeat every time. Every time I say that one, you know what I mean. So, those changes are not compiled. They are sent directly to the virtual machine that does that thing, and the UI can get updated. But actually, this works only in debug, because when we release, our changes are compiled, and of course, we cannot change them. But actually, we have these two different steps based on what kind of build we are trying to make. So under the hood, what we have are several layers. The first one is the engine. And the engine is actually written in C or C++, actually, I guess both of them. And is compiled using the Android NDK or LLVM for iOS. So they both run without overhead. On top of that, there are the framework and the apps that are written in Dart. I feel strange going back to my computer to change the slides. OK, so we already said that our compiler only compiles the code when we are releasing. And it actually compiles it into native code with the Dart compiler for Android. And it uses some sort of a ahead-of-time compilation for iOS, so that we have less overhead possible, and it shouldn't really add much latency to our UI when we start actually using it. So the engine is composed by three main parts. The first one is pretty known. I mean, who knows what Skia is and what does? OK, so Skia is a bidimensional graphic engine that actually is what powers Android, Chrome, Chrome OS, I guess also Firefox, and a bunch of other things. If you want to learn more about Skia, it's pretty low level on Android. I mean, it's pretty deep in our system. There are a bunch of articles that are quite interesting. If you want, I can tweet them later. But it's quite heavy to read. I mean, I didn't have the courage to read them all. So together with Skia, we have the Dart virtual machine and Dart compiler. And then there is the manager for the text. That means everything that draws it. Because, yeah, Skia could do that, but you don't really want it to do that. It's not good at it, mostly. So on top of the engine, we have the Flutter foundation. This is the core of Flutter, like the basis that our framework needs in order to work. If you go up a new level, we still see something strange. We see animation and gestures. I mean, we can be OK with painting. I mean, it's OK. Sounds like a low-level things. But animation and gestures? Animation and gestures are not managed like we are used to on Android. But they have been created in order to be extended. We see that in a few moments. But remember this chart. On top of that, we have the rendering pipeline. Because we saw earlier that they don't use the Android one. They redraw the pipeline so that they could do, between the other things, also this auto reload stuff. Because you can change the UI and see that changing with the auto reload. But they couldn't really achieve that by using the Android pipeline. They needed to write something different. And of course, we finally get to the fun part, the widgets. These are the base widgets, the one that gets then extended by both Material and Cupertino themes. Okay? This is more or less how Flutter is done under the hood. And we said earlier that the hot reload is actually stateful. What does it mean? It means that imagine that you are in the 10th step of your navigation, and you found something that you need to change in that activity. What happens usually is that you have to rebuild your app and navigate again to the point where you were and do the exact sequence of operation that brought you there. With Flutter, this is not the case. Once you launch the hot reload, you will stay exactly where you are, with the same data and the same operation that you just performed. So that's why they call it fast development, because all that dead times that we used to spend every day when we are deep in our hierarchy and we try to navigate back and forth to find the change we just applied is not there. We don't have the time with Flutter. With Flutter, we keep our state. And this is actually quite important, I think. Well, if you check the hello world of Flutter, you see something that is quite strange. Let's take a look, because this is actually connected to the state. So, this is our, let's say, main page, okay? Our first activity. As you see, is like 2 lines of code. There are no on create, on resume, on start, on destroy. There's nothing like that. The only thing we see is this method there, the create state. What it does, this create state, is creating a new state of the private type my own page state. Okay? So what we're doing here is creating a state that we're going to use together with the home page. So when we call the create state, we create a state by building it. So the build context is nothing really related with Android. I mean, we needed to create new widget, but it's not really like the context on Android. It's not a code object. And so, to repeat once more, we have our state that is associated with our page, and we create it by building it, okay? But there is something strange. I mean, it returns a widget. So instead of actually attaching a state to a widget, what we do in Flutter is using the state itself to create the widgets, so that we are sure that they are tightly coupled, and when a widget is removed by the hierarchy, the state is destroyed, and when and if the widget is added again to the hierarchy, a new state is created. But so far, we didn't see anything dynamic. I mean, we just created a state. What if we want to change it? And we have the last method. That is the set state. What happens when we call the set state? We actually don't change our state. The state is immutable. So we destroy our state and create a new one. Of course, not everything in Flutter is stateful. We can have both stateless widget and stateful widget. I have to come back for the animations, I'm sorry. So, what is the difference between the two? The first one, the stateless widget, receives some sort of states from its parent, and when we try to build it, use these variables that are stored as final fields to create itself. And that doesn't change. An example of a stateless widget is the text. I mean, the text view doesn't really have a state. Okay? Oops, wrong animation. While the stateful widget, I believe I had an animation there, are actually able to generate a state and to change related to that state. So imagine which kind of widget do you think that could actually be a stateful one? The first widget that comes to your mind. The first thing that when you don't set the proper background doesn't look good on Android. Nobody? Starts with B? Yeah, good. You get a sticker. So, as I was saying earlier, Flutter has been created to be extended. One example of that is the gesture system that is actually created in 2 layers. The first one is the one that detects the touches that we make on the screen and actually group them. The second layer, which relies on top of that, is the one that understands what kind of gesture we were trying to make and actually returns the gesture to us. Why this is important? Because actually all the gestures are implemented in this exact way. So we can create our own gesture, and it will be treated exactly as the standard Flutter gestures. So we are not adding something that was not meant to be added. They want us to create new gestures. I can't think of any, but it was actually interesting that they did. So, we didn't see how to create the UI so far. So, how many of you think that they actually use some sort of XML? One? Only one person think that they use XML or any kind of other markup languages? Well, you know more than I do then. What happened here? My slides are still going. I broke it. So, no, there. Please look there. Oh, here as well. Ah, it's back. So, actually, no, they don't use any markup language. If you're familiar with Anko, it's more or less the same concept, like it or not. And actually, we write everything in Dart. So let's take a deeper look to this, because this is quite hard. Let's start from here. So the first thing we do here is creating a scaffold. That is a container, because of course, we need a container to put all our widgets. The next step will be for us to add an app bar. And this is quite easy. I mean, we can just call the constructor from the app bar. And as I was saying earlier, we can put anything we want in there. So here we put a text view, because more or less it was the example. But we could have added everything, because this title actually takes a widget. So if we have our own widget that is, for example, a text view and a switch, we could just add it there. And if we go on the body, we see that it takes itself a container. Because of course, I mean, we need to tell the body how to behave. They're not synchronized, or they are? What? So after we create our container for the body, we decide that we want to align all our items vertically, like if it was a linear layout. How we do that? We just create a new column, and then we actually just say, yeah, align it to the center. And these are all the children that you need to have. Of course, this is a very basic example, but it actually makes sense. What we do is create an app bar, put in a view inside the app bar, and then when it comes to the body, we just keep on adding view. And we decide the layout up front. Of course, since we have material design, we need a floating action button. And what is really surprising is that the floating action button is not any sort of image button. So we actually need, of course, we need to tell him what to do when we click, but we also need to tell him what we want inside the floating action button. And this is an icon, okay? So we compose our interface by keep on creating new widget that can be nested at any level. Of course, this was not the ideal code that we would write, because, I mean, this is not really readable or maintainable, but it served the purpose of giving an overview. So we can actually understand how Flutter works, that we can compose UIs by simply putting the widgets one inside the other. Another thing that I really, really loved is the navigator. I mean, how many times did we struggle with the navigation on Android? I mean, it can take ages to understand how we need to design the navigation. If we have to go back, if we have to go up, if we have to stay at the same level, this is kind of strange. So, just to be clear on what I mean, this is the example we're gonna study. So, this is pretty simple. We press a button, launch a new view. Then we have a button that closes the view, or we go on the up button, and we get back to the main. How do we do that? Actually, it's fairly easy. So we start by creating a new stateful widget. Because, of course, being another view, another page, we need a state. It's quite similar to what we just saw, right? There is only one difference. And this is the constant, because that constant is what we will be using to actually telling our navigator where we want to go. So, of course, we need to link the navigator somehow in our application. And how we do that? I mean, this is our sample app. There's nothing fancy there. So what we do is actually adding just a couple of lines. So the first thing we need to do is create a new route name for our page. And we do that in the first line, where you see the map. It is a map of a string, and the widget builder, that is this lambda here. Of course, if we had others, we could have actually added many more, because once we add them to our application, they are stored there. So we create our map, and we pass it to our application. And so far, there was nothing really hard. So let's see how we can actually go to page 2. Any guess? OK, I'll tell you the solution. So the way to go where we need is actually calling navigator.pushNamed. And the parameter we see here is what we defined earlier. So it's the constant that we declared inside our new page. And getting back is even easier, because the only thing we need to do is actually pop ourselves from the application. If you're curious about Flutter as I am, the documentation is at flutter.io, and the project is open source. So if you're willing to study it and contribute, you're more than welcome to do so. And if you're interested in instead what we do for the community, these are all the links from our group. And this is mostly all of it. So thank you again for being here. I guess we have time for questions, if there are any. Yeah, if you want to ask questions, just go to the mic.
You said that it's alpha quality. How alpha? Would you actually ship something with it?
That's a good question. Personally, I'm not really afraid of alphas. I mean, we actually use the alpha plugins in production. And there are stories of people that actually shipped something with Flutter. But being such a new technology, I wouldn't have the trust in myself to do that. Because even if the framework is in alpha, and you actually know it very well, you can still risk it. But I wouldn't do that with a language that I don't know that much. So personally, no. But I know that there are quite a lot of successful stories that actually landed on both the App Store and the Play Store, and they work quite well. So to answer your question, maybe. It depends. Other questions?
When you push a new screen, so that's just adding a view, right? The second screen. So would you use that instead of fragments? Is that? I didn't quite understand how that would relate to if you're using like an activity in a fragment in your app currently.
No, actually there were no activities and no fragments. And if you can, don't use fragments at all. This is just actually a Flutter kind of view. So the activity, because of course, under the hood, it relies on an activity that extends the Flutter activity so that it can understand the pipeline and all the things related to Flutter. But no, it's just a Flutter view. It's not an activity. At least in this case. I mean, if you wanted to launch an activity, you could do that.
Cool. Have you spoke to any iOS developers about this? Because I can imagine it being a bit prickly if the Android team are like, oh, we like Flutter. By the way, we don't need you anymore. So what's their feedback? Like, have you got any ideas on how you bring this into a bigger company?
I have no idea. I don't speak to iOS developers. They're mean people. Now, apart from that, I mean, if you were to bring Flutter into a big project, it will be harder. Because Flutter requires any way to create a new project. And that you can import, at least as of today, all your code into one project. Maybe if you have a very big project, you can think about creating a subcomponent that you can then distribute via Cocoa Pods on Gradle. But I don't think that, as of today, a big company could make the switch right away. Could take quite a lot of time.
Are you familiar with React Native, and how does this project compare pros and cons? If you are familiar, if not, then you can just skip.
Honestly, I didn't play much with React Native, but I guess at the end of the day, they are always mostly similar. If you already started with React Native, there's no need to switch to Flutter. If you are evaluating, just check which one you feel better about. I don't think they're that much different. I mean, React Native for sure is way more mature, but I think they more or less solve the same duty. If that answered your question, I'm not sure.
Yeah, more or less. I was wondering about the pros and cons, but if you don't know, it might be hard.
Well, I don't like JavaScript, so that cons. I don't like Dart, but I don't like it less than I don't like JavaScript, so that's a pro. So no, I don't have any other thing. It's just a choice for me. Other questions? Okay, so thank you again for coming.